A system consists of three masses m1, m2 and m3 connected by a string passing over it pulley P. And the mass m1 hangs freely, and m2 and m3 are on a rough horizontal table with the coefficient of friction being mu. The pulley is frictionless, and of negligible mass, the downward acceleration of the mass m1 is okay. So, to understand the concept of this, or to understand how to solve these kind of questions, we'll for the initial set of problems, what we'll do is we'll try to solve every question in the detailed way, and then as we slowly pick up pace, we'll start to do use formulas directly. Okay, so I'm not going to use any formula directly here. Instead, we'll see how to solve each and every subpart of the question very correctly. Okay. So first thing is to identify the direction of motion. So the direction of motion here is downwards, right? The downward acceleration is being said. Downward acceleration. Okay. So direction of motion is downwards. So what will be the way to choose? What will be the way to choose the sign convention? Along the direction, we'll choose it as, along the direction of motion, we'll choose it as positive, and against the direction of motion, we'll choose that as negative. Okay. So this is applicable for the first mass m1, right? This is applicable only for the first mass, not for the second mass and third mass, because they are moving in a different direction, right? So this is negative. So we're talking about only about the first mass. So now what I'll do is I'll draw the first mass separately. Okay, so let's do that. So this is the first mass, right? This is the first mass, which is m1. Now let us first draw the diagram. Draw the free body diagram and represent the various forces acting on it. See, it is the first force would be m1 into g acting downwards, and the upward force, how do we mark that? See, this is the point of contact, and tension in the string will be always acting away in the direction that is away from the point of contact, right? Away from the point of contact. So if we have to draw the free body diagram, we have to look like this. We have tension acting opposite direction, right? And then we have m1g acting in the downward direction. And what is the net direction of motion? The net direction of motion is acting downwards. So what do we do? Direction of motion, along the direction of motion, we'll take things to be positive, and against the direction of motion, we'll take it to be negative. As we did in the previous questions, we need to understand whether the motion isn't taking place in the x direction or in the y direction. So let us see. Now, wait. So if we closely try to understand the motion of this object, this mass m1 here, see, this mass m1 is moving in, it was, say for example, this m1 was hanging here, right? So this m1 is acting, it is moving downwards, right? The downward acceleration is being asked. So the mass is moving only downwards. It is neither moving upwards nor is it moving in the sidewise direction. So the pulley was connected to the mass like this, right? And then the mass was moving only downwards, and it has neither a movement towards left nor movement towards the right. So it is moving only in the downward direction. Okay. So that's which means considering this body, there could be fx and fy. See, if there has to be fx and fy, then we can write that f is equal to root of fx square plus fy square. Now, what is fx? Fx is equal to, right? Fx is actually equal to m into ax. And what is fy? Fy is equal to m into ay. Now, is there any motion in the x direction? No. If there is no motion in the x direction, it implies that velocity along the x direction is 0, which otherwise implies there is no velocity, there has to be no acceleration, right? So we can write that fx is equal to m into ax, which is equal to 0, and therefore fx is equal to 0. Okay. Now what is Fy? See, Fy is equal to, so the net force we have to take into account here. So what did we say the net force? How many forces are there? There are two forces. And how do we write that? We write the positive forces first. So let me write down positive let me write down positive m1g first. So we have positive m1g. What is the next force? The next force is minus tension is equal to, what is the mass? Mass is m1 is equal to m1 into ay. Now since there is only ay component, I can replace it with y, with replace ay with a. Okay, so the equation we get is mg minus t is equal to m1a. So let me highlight this equation. Let me highlight this equation over here. Now we'll use the same concept to solve the free body diagram for the next for the rest of the two blocks as well. Okay, so for that let me take a different space. Yeah. Now let us discuss about the second body here, which is M2. Okay, M2. So for M2, we know that there's a surface here, right? And a pulley is attached to the surface, and a string is passing through the pulley, which is connected to the mass, M2, which also is connected to a third mass M3, which is not something we will discuss here. So let us try to label the forces here. But before that, first let us identify where is the net direction of motion happening in. See, if m1 is going downwards, I repeat, if m1 is going downwards, it simply means that m1 is pulling m2 and m3 along m1, right? So m2 and m3 will be pulled along with m1. Now m2 can't drop down. Why? Because there's a surface here. m3 can't drop down. Why? Because there's a surface here. So the only possible direction of motion for m2 will be to follow the table like this, along the pulley, right? So follow the table like this, which means m2 and m3 will follow the table like this. It will move towards the left. Okay. So the net direction of motion is towards the left. Let us now draw the various forces. So we know that there is a string attached here as well. So tension will be originating from the point of contact, but away from the point of contact. Tension will be originating from the point of contact, but away from the body, right? Away from the body. So this will be the tension acting on it. Now we're not done here. Why? Because it is given that it is on a rough horizontal table. So it's on a rough horizontal table, which means what is acting here? Friction is also acting. So we know that if the direction of motion is towards the left, then friction will be acting towards the right, because friction is an opposing force. So if the direction of motion is towards the left, then we have friction which is acting towards the right. So friction would come into picture here, and frictional force would be acting. Let me write it as Fr. Okay. What else do we have? We also have the normal reaction acting here, and weight of the body acting downwards. M2g. Okay. Now let us find out Fx and Fy. See, is there any motion in the vertical plane? For this mass M2, motion is taking place only along the x direction, right? Motion is along the x direction only. So if the motion is along the x direction only, what does it imply? It implies that Vx is equal to 0. I'm sorry, not Vx. Vy is equal to 0. And if Vy is equal to 0, it means that Ay is equal to 0. And if Ay is equal to 0, it further implies that M into Ay is equal to 0. What is Ma? Ma is F, so May is Fy, therefore Fy is equal to 0, right? And if Fy is equal to 0, this gives an indication that N minus M2G is equal to 0, right? Or otherwise, well, to be more precise, we can write that if Fy is equal to 0, we can write that N is equal to M2 into G. Okay, so this is the condition with Fy. Now let us discuss what happens with Fx. So when we consider forces along the x direction, let us draw the free body diagram. So we have an mass here, my bad. So there is tension here T. Okay, wait, should we write T1? Maybe that would help us, right? So let us write it here T1 here, in which case we'll have to replace the entire terms here also. So this is also T1, this is also T1. Okay, right, now it makes sense. Okay, so we written a T1, right? T1, and we'll write this tension as T2. So T2 is acting towards the left. So T2 is acting towards the left. And what else is acting? We also have friction force Fr, which is acting towards the right. Now, what is the net direction of motion? The net direction of motion is towards the left. The net direction of motion is towards the left. Therefore, this much direction of motion. So all the forces acting along the direction of motion. All the forces acting along the direction of motion, which means there's only one force here, which is T1. So T1 is acting along the direction of motion. Therefore, T1 should be taken as what? T1 should be taken as positive. Now, T1 should be taken as positive. Fr would be taken as negative, right? Fr would be taken as negative, and T2 would also be taken as negative. So if we had to write the equation here, how do we write this? We write that sigma Fy is equal to M into Ay. So what is sigma Fy? The sum of all the forces. So if we take the sum, we have plus T1. So we have plus T1 minus T2, then minus Fr is equal to M into Ay, right? Okay, so what we need to understand here is what is, okay, let me rewrite this equation one more time. So we have T1, right? T1 minus T2 minus, now what is Fr? See, we know from the equation of friction that Fr is equal to mu into, right? Mu into N. And what is N here? N is M2 into G, right? So Fr is basically equal to mu into M2 into G. So if I write it over here, Fr is equal to mu into M2 into G, which is further equal to M into Ay. So instead of Ay, I can replace it as A, right? Because all the systems have common acceleration, A. Okay. Now, okay, so that's it with the second mass. Let us now discuss about the third mass. So this is about M2. Now so the table. Right, so let us first draw the table. What is attached to it? Pulley is attached to it, right? Mass is M2 is connected, which we don't need to consider here. So we need to consider only the mass M3. The only mass connected here is M3. And since there is a point of contact here, tension will be acting along this direction, right? Sorry, tension will be acting against the direction, against the point of contact, away from the point of contact. So let me mark this as T2, right? This would be T2. Did we take T2 there? Yeah, T2. Okay. So it's T2. What's the net direction of motion? Net direction of motion is towards the left. And what else will be acting here? Since both of them are on the same table, frictional force Fr would be acting, right? The vertical forces here would be normal reaction N and weight acting downwards, which is M3 into G. Now let us try to write down. Well, let us try to write down. Okay, let us not skip steps, right? Let us write things in detail. We'll write down both the Fx and the Fy values here. So the direction of motion here, direction of motion is only direction of motion, or say direction of motion is restricted towards the x-axis, which means there is no motion along the y-axis. Now, if there is no motion along the y-axis, what does it further implies? It implies that Vx is equal to, it implies that Vy is equal to 0. And if Vy is equal to 0, Ay is equal to 0. And therefore, if Ay is equal to 0, M into Ay is equal to 0. And therefore, if M into Ay is equal to 0, what is F? F is equal to Ma. So what is M into Ay? It is Fy. So Fy is equal to 0. And therefore, we can say that normal reaction is actually equal to M3 into G, right? So this is the case with x direction. Sorry, y direction. Now let us resolve the forces along the x direction. So again, what do we have? Along the x direction, we have velocity in the x direction, we have acceleration in the x direction, and therefore we have mass into acceleration around the x direction as well. So we can write that Fx is equal to m into ax. Now let us draw the free body diagram here. So if we draw this mass m3 here, what are the various forces acting along the x direction alone? So we have one force acting along the is Fr, right? And the other one acting along the direction of motion is T2. So the net direction of motion is towards the left. Net direction of motion is towards the left, and we'll mark that force as positive. And the one which is acting towards the right, we'll take it as negative. So sigma Fx, so when we take actually sigma Fx is equal to max, what do we write here? We can write that plus T2, right? So you can write that plus T2 minus Fr is equal to m into, instead of ax, we can write a here, right? Okay, so my bad. This should here be not ay, right? It should be ax. My bad. Oh, I wrote here sigma fy as well. Okay. Oh, right. I'm sorry. I'm so sorry for that. So it will be mx is equal to ax. Yeah. Okay, that's correct now. Okay. Okay. So it's T2 minus Fr is equal to. Now, what is m here? M is m3, right? M is m3. So we have m3 into a. Now, what is Fr? We know that Fr is actually equal to mu into n, right? So Fr is equal to mu into n. What is n? N is m3 into g. So we have m3 into g here. So this becomes mu r Fr is equal to mu into m3 into g is equal to m3a, right? So let me highlight this equation as well. Now let us bring all three equations together. Which all are we talking about? So we have this equation number 1. Okay. And from the second case, we have, so equation number 1, equation number 2, and we have equation number 3. Equation number 3. Okay. Now we'll try to solve these equations simultaneously. How will we do that? Simple. We'll just add these three equations together. We'll add the LHS and RHS together. So I'll write the tension portion separately. So we have T2 plus T1 minus T2 minus T1, right? Minus mu into m3g minus mu into m2g plus m1g is equal to m3a plus m2a plus, oh wait, right, m here, sorry, it's m2a plus m1a, right? Now let's see what all things will cancel off here. T2 minus T2 0, T1 minus T1 is 0. Then what we have here is, if we take minus mu common here, take minus mu common here, so we take minus mu g as common. What do we have in the bracket? We have m3 plus m2 plus m1 into g is equal to, a is common, a into m1 plus m2 plus m3, right? Now, we need to go back to the question because we are missing on some point, which, oh, it is given in the question that m1 is equal to m2 is equal to m3 is equal to m. Okay, right. Now let us come back. So in this case, if m1 is equal to m2 is equal to m3 is equal to m, then this overall equation will modify to minus mu g into, right, m plus m plus m into g is equal to a into m plus m, right? And what will this give us further? 2m into mu g plus mg is equal to 3m into a, or 3m. Okay. In which case, what else is common here? If we take mu into g common, okay, let's cancel out m first. So this becomes minus 2 mu g plus g is equal to 3a, right? And what is that we need to find out? We need to find out the value of acceleration. So a will be equal to, take g common, minus 2 mu plus 1 the whole upon 3, or a is equal to g into 1 minus 2 mu upon 3, which gives us the final answer as g into 1 minus, this is option 1 minus 2 by 3, option C. Okay. So we'll go through the problem once again. So pulley, M1 is acting hanging freely, M1, weight, tension is acting away, no horizontal motion, only vertical motion, forces balance, equation number 1. Second case, M2 is sliding towards the left, no motion along the y direction, motion is only along the x direction. T1, T2, two tension acting, friction is acting because the table is given to be rough. Fr is equal to mu into n, Fx equal to max, against the motion negative, Fr is against the motion negative, T2 is against the motion negative, towards the motion T1 positive, towards the motion T1 positive, T1 positive, negative, negative, equation number 2. Now for the third block, no tension here, only friction acting here. T2, Fy is 0, sigma Fy is 0, and n is equal to m to g, right? So we'll actually have to mention the sigma F here, right? That would be more correct. Sigma F equal to 0. And N2 is N is equal to M2G. Fi is equal to mu N. Fi is equal to mu N is M3G. So it is M3G. Fx, two forces acting along the direction of motion is T2, acting against the direction of motion is Fr. So plus minus third equation. And then what do? We bring all these three equations together. We add them. Then we invoke M1 is equal to M2 is equal to M3, M. Then we just find out the answer. Okay. So that's how we approach any question based on block, tension, block, and pulley, all kinds of these questions. Okay. So you separate these. Treat these values separately, right? You treat these cases separately, and then solve the individual, free body diagrams. And then what we do is we try to come up with the necessary equations and solve all of them together. Okay, right. Having said that, let's move on to the next question.